Good afternoon. Thank you so much for joining our webinar today. My name is Genevieve. I work for Cara Technology. My role is Customer Education Manager, and I will be hosting our webinar this afternoon. In the background is my very esteemed colleague, Gordon, who will be fielding the Q&A as well. So feel free to put any questions over to him. But thank you very much for joining our webinar. We're going to be exploring the sensory experience, understanding the science behind our senses. We're going to explore how our five core senses of sight, smell, taste, touch, and sound work together to create the full flavour experience. We'll share practical insights you can use in product evaluation, quality control, and development, and we hope you'll come away with a fresh perspective on the power of sensory perception. Before we dive in, a few quick housekeeping points. So feel free to submit your questions anytime through the webinar Q&A function in Zoom. Little queries, Gordon will be able to answer on the fly, but anything that's a bit broader that we think everyone would benefit from, we'll address at the end of the webinar. If we do run out of time, please be reassured that we will follow up on additional questions by email. If you have any technical issues as well, let Gordon know in the Q&A in the chat, and we'll do everything we can to help you out. We are recording the session today and intend to share it on YouTube in the next few weeks. The session is interactive, so think about your own products and experiences as we go along. Jot down any questions or observations for discussion later. Some of it you might know already, but I hope that everyone on the webinar today can take something away that lets them expand their understanding of how incredible your senses really are. And with that covered, let's get started and explore how each of our senses contributes to flavour perception and shapes how consumers experience your products. So when we talk about sensory experience, most people jump straight into flavour or taste, but it's actually a lot more than that. It's the whole interaction that we have with a product. So how it looks, smells, sounds, feels, and yes, of course, tastes. Now, traditionally, this has been broken down into the five classic senses of taste, smell, sight, touch, and hearing. It's a simple framework that you'll find in almost every biology textbook, and it's a great starting point for the sensory analysis that you might do in your production facility. Of course, human perception is far more complicated than that. We pick up on things like temperature, texture, motion, even chemical sensations. So the cooling of menthol, the heat of chili peppers. There's fascinating research that demonstrates that the human body has over 50 different senses, but for our purposes, we're going to keep the focus on the five core ones. Those are the ones that are most directly tied to sensory analysis. So let's quickly walk through them one by one. Let's start with sight. Before you've even tasted a product, we're already making judgments based on the branding, the packaging, and the look of the product itself. They all influence consumer expectations. Does it look fresh and inviting, or does something not seem quite right? Then comes hearing. So think about the hiss of a can when you open it, the snap of a biscuit. Those little sound cues tell our brains something about quality and freshness, even before we've taken a mouthful. Next is smell. The moment we open the packaging, aromas will rush in. They set the stage for everything that follows, defining much of how we'll experience flavour. With touch or mouthfeel, this is where the texture, temperature, and carbonation come into play. Is it crisp or creamy, thin or full-bodied? These subtle sensations will shape how enjoyable the product feels in the mouth. And finally, taste. So here we detect bitterness, sweetness, sourness, saltiness, and through retronasal olfaction, which we will cover shortly, we unlock a whole second wave of aromas that add depth and complexity. Put all of this together and you get the full sensory picture. And ultimately, it's through these experiences that consumers decide, does this product meet my expectations? And more importantly, will they buy it again? So every day we're already experiencing the world through our senses. They shape how people understand their surroundings and connect with them. Think of the brain like a computer with thousands of wires leading to different regions. And these connections help us to process sensory input, interpret it, and then choose how to respond. Just like memories, sensory experiences are stored so we can draw on them later to make sense of new situations. And after we've experienced something a few times, we can usually imagine it without the actual stimulus. like recalling the smell of coffee or the sound of ocean waves. These associations guide us in sorting experiences into good or poor quality. So let's look at a few examples. Well, with sight, a freshly painted house with beautiful clean lines can feel really uplifting. Chipped and faded paintwork, on the other hand, immediately signals neglect. With smell, freshly cut grass will bring back memories of summer and feels refreshing. But spoilt milk, that sharp, sour odour, will instantly tell us that something is wrong. With taste, think about a rich, freshly brewed coffee. It's warming, indulgent, it lifts your mood. In contrast, a metallic taste in water instantly feels unpleasant, potentially even unsafe. With touch, the warmth of the sun on your skin, it's relaxing and comforting. But the scratch of a wool jumper quickly turns cosy into irritating. And with hearing birdsong in the morning, that can create calmness and can signal a fresh start. On the other hand, if you think about your operation facilities, the screech of metal on metal can feel jarring and really disruptive. While each of us has personal reactions shaped by our own experiences, sensory evaluation for product quality requires training ourselves to reduce that subjectivity. The goal is to move from what you personally like or dislike towards a more objective, consistent way of judging quality. So let's go through those senses in a bit more detail. Let's start with that first touch point that most consumers have, the visuals. It's the first signal of quality. If something doesn't look right, consumers won't even give it a chance. They'll move on before tasting, smelling, or touching, simply because the appearance didn't inspire confidence. And when a product falls short visually, shoppers will usually choose an alternative that looks better cared for. Poor visuals can show up in lots of ways: misaligned or torn labels, dusty or dented packaging, scuffed surfaces, inconsistent fill levels, or even loose seals that make the product look tampered with. On the flip side, appearance can be a powerful trust builder. Clean, neat, and consistent packaging sends a clear message. This product is made with care and held to high standards. It's reassuring to the consumer that the quality inside matches the quality they see on the outside. In short, a strong visual presentation sets the stage for a positive experience long before the customer really thinks about the product, if they've opened it or used it yet. So think about the last time you picked something off a shelf. The way the product looked and the words on its packaging probably shaped your expectations before you even opened it. Those visual cues and descriptions set the stage for your whole product experience. Imagine grabbing a juice labelled as citrus. Instantly, you're expecting something bright, tangy, and refreshing. Or a bar of chocolate marketed as dark and rich, and right away, you're picturing bold flavours and a velvety texture. And if a bag of crisps says it's crunchy or crispy, your brain is already anticipating the satisfying sound and bite. We also lean on familiar ingredients to fill in the picture. So vanilla or cinnamon makes us think warmth and sweetness. Smoked flavours, well, they lend us to expect something savoury, maybe even a little bit rustic. So the language on the packaging matters as well. It's not just decoration, it's setting the expectations. And when those expectations are met, it builds trust. Consumers don't just want that match once. High quality products deliver on their promises every single time. If the label says fresh, fruity flavours or rich, decadent texture, it has to hold up, whether it's the first mouthful or the last one from the pack. Once a product is opened or served, consumers make a second visual judgment on the product this time and not just the packaging. This moment is just as important. It reinforces their expectations for taste, texture, and overall quality. Colour plays a huge role here. Lighter colours often signal delicate, mild flavours. Think of a pale yellow lemonade. You expect a gentle citrus tang. On the other hand, rich or dark colours usually suggest something more robust, like the depth of dark chocolate or a hearty tomato sauce. But when colours change unexpectedly, it can be a massive red flag for quality issues. For example, oxidation can turn fresh fruit juices a dull brown. Dairy left in light or heat will pick up a bit of a yellow tint. Even natural pH changes can shift colours, making them unstable and potentially moving them a long way from what you were expecting. Cross-contamination is another culprit. Ingredients bleeding into each other can create strange, unintended colours. Prolonged heat can darken foods through reactions like the Maillard effect, which is the same reaction that gives bread its golden crust, but can be a problem when it happens in the wrong place. And that's why industries like juice and dairy and breweries use tools such as spectroscopy to measure colour precisely, ensuring batch-to-batch consistency. Visual standards are also common. Products are compared to benchmarks to make sure they look exactly as they should. And it's not just about the science. When colours change, sensory panels often pick up related shifts in flavour, aroma, or texture. Their feedback, combined with analytical data, gives a complete picture of what's happening and whether the product still delivers the quality consumers are expecting. When it comes to drinks, clarity is another key visual cue. Expectations vary depending on the product and how it's positioned. A juice or beer labelled as natural, cloudy, or unfiltered might actually use turbidity as part of its appeal, whilst other products are, of course, expected to be crystal clear. In the lab, clarity can be measured using turbidity meters, spectroscopy, or simple comparisons to visual standards. Shelf life testing is also essential since clarity often changes over time. Juices and teas may become cloudy as proteins and polyphenols form insoluble complexes, changes that can be accelerated by heat or temperature swings during storage. Clarity issues can also signal microbiological contamination. Spoilage organisms like lactobacillus or pediococcus produce exopolysaccharides that stay suspended in the liquids, creating haze in juices, dairy, and other beverages. Preventing this means maintaining strict hygiene from cleaning and sanitizing equipment to careful handling of raw materials. Another common issue is pectin haze, especially in juices made from apples, oranges, and citrus fruits. Pectin, a natural thickener, can cause a haze if it's not fully broken down during processing. That's fine, even desirable in juices marked as cloudy or natural, but it is considered a defect in products where clarity is the expectation. Clarity doesn't just affect how a drink looks, it often ties to flavour and quality too. By understanding what's causing the haze, producers can better control it, maintaining the product's intended appearance and consumer appeal. Okay, moving on to aroma. Aroma is what we perceive when we smell something, our olfactory sense picking up volatile molecules in the air. Of all our senses, it's capable of distinguishing the most diverse array of compounds, giving us an incredible ability to identify and enjoy complex flavours and scents. In fact, humans can be more sensitive than the best electronic detection systems by a factor of more than 10 million. Some aroma compounds can be detected with fewer than 100 molecules in a single sniff, and we can even discriminate between isomers, so compounds that are chemically almost identical but can smell really different. We don't smell a product as a single scent. Each sniff delivers a mix of multiple aromatic compounds, and it's our brain that combines these building blocks to form the aroma we recognize as, say, fresh coffee, ripe strawberries, or a hop-forward pale ale. Scientists don't yet fully understand exactly how the olfactory system works. What we do know is that about 350 genes code for olfactory receptors, which are specialized proteins in the nasal cavity that respond to specific volatile molecules. Most odor molecules trigger multiple receptors, and each receptor responds to particular chemical structures rather than combinations. When we inhale, the molecules travel through the air into the nasal passages, bind to these receptors, and send signals to the brain. And it's in the brain where all this information is processed, interpreted, and finally experienced as the familiar smells and aromas we rely on to judge and enjoy products. Temperature plays a big role in how we perceive aroma. It affects volatility, how easily aromas compounds evaporate and reach our olfactory receptors. Warmer temperatures make compounds more volatile, releasing scents into the air and intensifying that aroma. Colder temperatures, on the other hand, can suppress that volatility, making aromas harder to detect. And this is why temperature really matters when you're doing sensory testing. To keep evaluations consistent and objective, samples should always be served at the same temperature. That way, every sniff and every tasting session gives a fair, reliable representation of the product. So, our sense of smell is hardwired into the emotional center of the brain, which is why smell memories are so vivid and often feel different from other types of memories. Aroma molecules are detected by olfactory receptors, usually at the top of the nasal cavity in the olfactory epithelium. The exact location will vary between people, so any diagrams like the one you've got on screen that you see are simplified for illustration and definitely not a precise anatomical map. Sensitivity to specific compounds also differs significantly from person to person. Some people will have a genetic condition called anosmia, which makes them unable to detect certain smells. We perceive aromas in two ways. First, there's orthonasal olfaction, or upward sniffing, and they are the scents we pick up when we inhale through our nostrils. Then, once we've started consuming a product, there's retronasal olfaction. Here, aromas are released from the food or drink in the mouth and travel to the olfactory receptors through the back of the throat. Interestingly, the same compound can smell different depending on whether it's detected orthonasally or retronasally. Both systems work together to shape our perception of flavour and overall enjoyment. Smell is also directional, so each nostril senses independently, and the slight timing differences allow the brain to locate the source of a scent. This directional sense isn't just a funky biological quirk, it has practical value. So, animals will often rely on it for survival, for finding food, detecting predators, or navigating. Humans benefit too, whether it's identifying the source of a delicious aroma in the kitchen or detecting potential hazards like the smell of smoke. For an extreme example, camels are really cool. Camels can detect the compound geosmin, which has an earthy character to it, and it signals water. They can smell that from up to 50 miles away, allowing them to navigate vast deserts just through directional smelling. While we're not quite as sensitive as camels, perhaps that just goes to highlight how powerful and directional our sense of smell can really be. So I mentioned anosmia there. Anosmia is sometimes called nose blindness, and it is usually genetic. So some aroma compounds are affected more than others. For example, about 50% of people cannot detect the compound beta ionone, which has a violet-like, Parma violet-like floral scent. In contrast, only about 3% of the population are anosmic to isovaleric acid. That's the sweaty foot cheesy odor you get with stale socks. Roughly 23% can't smell isobutyraldehyde, which is a grainy character. Most of us will have at least one compound we can't detect. This is called a specific anosmia, specific to an individual chemical compound. For sensory panels and sensory panelists, this isn't necessarily a disqualifier. In fact, knowing a sensory panel's specific anosmias can be really useful because you can use it to identify particular compounds through a process of elimination when you're tasting as a panel. General anosmia, on the other hand, is a complete loss of smell. It can result from physical damage, so head trauma, sinus infections, COVID-19, or neurological issues such as Alzheimer's. COVID-19 brought this into sharp focus. Many people experience sudden anosmia without nasal congestion. For most, the sense of smell eventually returned, but recovery could take from weeks or even months, which is something to keep in mind when you're considering the ongoing health and well-being of your sensory panel. Parosmia is another related condition. It's a distortion of smell, often unpleasant. Individuals will often describe odours as undescribable or indescribable or not of this world. So it's not that it will remind them of something else. Literally, it just has no context for them. And it can arise from viral infections, head trauma, neurological disorders. Um, Parosmia has become more widely recognized since COVID-19, with a lot of people reporting unfamiliar altered smells that don't resemble any known odor. Understanding anosmia and parosmia in your sensory panels can really unlock your sensory evaluations. By knowing which panelists might have specific limitations or distortions in smell perception, you can interpret results more accurately and even leverage their unique sensitivities to better identify certain aroma compounds. Okay, let's move on to taste. Sense of taste is entirely separate from smell, and it's actually much simpler. Taste comes from taste buds spread throughout the mouth and digestive tract, detecting the sensations we identify as flavour. There are five primary tastes: sweet, sour, salty, bitter, and umami. Recently, research in some animals has suggested there is a sixth taste, that of fat, which registers as richness or creamy. Historically, bitter and sour flavours were often associated with danger since they're common in spoiled foods. Many foods blend tastes, so sweet with salty or bitter with sour, which can also make it tricky for untrained sensory tasters to pick out individual flavours. You'll be amazed how often people confuse them. When building your sensory panel, it is really important to train your tasters not just on aromatic compounds, but on these taste compounds as well. Training tasters to differentiate between these tastes ensures everyone is on the same page, identifying and describing flavours consistently in your beer or juices, ciders, whatever product it is that you're making. So, when food or drink enters the mouth, taste molecules mix with saliva and interact with our taste receptors. How we perceive taste depends on factors like intensity, individual sensitivity, and even the pH in our mouths. Many aspects of life shape taste perception, be they age, genetics, health, medications, and environment. Viral infections again can alter taste, and neurological disorders such as Parkinson's or Alzheimer's can disrupt it as well. Certain medications, from chemotherapy drugs to antibiotics or diabetic treatments, can also impact taste. Interestingly, though, taste is one of the few senses we can influence with our minds. Imagine biting into a sour lemon right now. You'd likely to start salivating just through thought alone. That extra saliva actually dilutes the taste molecules, subtly shifting how the flavour comes across. Unlike sight, sound, or smell, taste is dynamic. Your own body plays a role in shaping the experience. We're born sensitive to sweetness, which likely evolved to encourage infants to drink breast milk. As we grow, exposure and experience teaches us to recognize the other tastes. Salt is unique because we can acclimate to it over time. Our taste buds adjust to different levels in our diet. Other tastes, like sweetness or bitterness, are more genetically determined, but also remain relatively stable throughout our lifetime. So, taste buds contain specialized gustatory receptor cells that detect specific molecules in food and beverages. When these molecules interact with the cells, they trigger electrical signals that travel to the brain, letting us perceive the flavor. Taste buds aren't just on the tongue, they're also on the roof of the mouth, in the soft palate, in the cavity behind the mouth and nose, and all the way through the digestive tract. These receptors don't just detect flavor, they can influence digestion and signal the presence of nutrients or potentially harmful substances. Unlike aroma molecules, taste molecules are non-volatile, meaning they have a higher molecular weight and cannot be detected by smell. Even if your nose is blocked, you'll still perceive the five tastes, but only when the molecules come into direct contact with your taste receptors. So, let's look at bitterness. Research has identified multiple bitter taste receptors. So, humans have about 25 different types of these receptors, each sensitive to different bittering compounds. This diversity in receptors suggests that our perception of bitterness is not fixed, but can be differentiated based on the specific receptors activated by different bitter substances. So, for example, caffeine, quinine, and certain peptides can all taste bitter, but interact with different bitter taste receptors. Within our Aroxa product selection, there are five different bitter flavors you can use to train your panel. They can vary not just in intensity, but perception threshold and also linger, as well as there being differing rates of blindness to different tastes. Moving on to sour, sour tastes generally come from acids, and different acids can create different sensations. So, lactic acid is often considered as tart, like yogurt. Citric acid gives the bright acidity of citrus fruits. Malic acid has a sharpness like an underripe green apple, whilst phosphoric acid is often described as more neutral. Acetic acid isn't sour at low levels, but it has a really strong aroma that can trick tasters into perceiving that sourness. Sourness adds complexity and contrast to flavour. In fruit juices, it will balance sweetness. In soft drinks, it signals freshness and drives refreshment. Sourness can occur naturally, like in citrus or fermented foods, but it can also signal microbiological contamination where it shouldn't be. Undesirable bacteria or yeast break down sugars and produce acids, which can indicate spoilage from poor hygiene, storage, or handling. Okay, salty. When people think of salt, they usually mean sodium chloride or classic table salt, the most common form. And most of the research is focused on sodium chloride or simple ionized salts like potassium chloride, whilst other salts are a lot less studied. Salt doesn't just contribute flavour, it can also control microbiology in food and beverage, or adding functionality as well, like in isotonic drinks. Interestingly, our perception of salt is adaptive, so reducing your salt intake over time and your taste receptors become more sensitive. Lower salt foods will, of course, taste saltier. Regular exposure to high salt diets dulls your sensitivity, creating a preference for stronger salt flavours. Unexpected saltiness can signal process issues, so that could be cross contaminations, seasoning errors, or uneven blending. And these problems can leave some parts of a product tasting excessively salty, affecting, of course, overall quality. Then we come to sweetness. So, sweetness comes from sugars like sucrose, fructose, and glucose, but also from non nutritive sweeteners such as aspartame, stevia, and sucralose. Even some alcohols can have a sweet taste. Sweetness is added to foods and beverages to enhance flavour, balance sourness or bitterness, and improve overall palatability. In drinks, the right level of sweetness can balance citrus acidity or the bitterness of coffee and tea. In fermented products like yogurt or certain alcoholic beverages, sweetness can soften tangy or bitter notes that develop during fermentation. Unexpected or excessive sweetness usually points to ingredient errors or cross contamination. So, using the wrong type of sugar or sweetener can also alter the tone of sweetness, changing the intended flavour profile. Quality control is key. Regular checks on sugar concentration, supplier audits, and raw material monitoring can help to ensure that your sweetness profile meets consumer expectations. And with growing global health awareness, understanding how humans perceive sweetness is also really important for product development, sugar reduction strategies, and maintaining the flavors consumers love. There is a great deal of research in developing new sweeteners, but wide individual differences in sweetness perception mean that some consumers may experience reduced or absent sweetness, which can limit the commercial viability of some of these alternatives. Onto umami. Umami is often described as a savoury or meaty taste, and it's more common in foods than beverages. It typically comes from glutamate-rich ingredients like mushrooms, soy sauce, and seaweed. A really common misconception with umami is that it has a smell, but it doesn't. It is purely a taste. Any aroma reminiscent of umami-rich foods comes from other compounds and not umami itself. pH also affects how we perceive umami. Compounds that register clearly in water may be muted in acidic foods or beverages, which is why umami flavour standards often don't translate directly into every product matrix. Now, you might have come across the concept of a super taster, and these are people with a heightened sensitivity to a specific bitter compound. Importantly, this heightened perception does not extend to other tastes like salt, sour, or sweet. Being a super taster doesn't improve the sense of smell, which plays a big role in overall flavour perception. So, while they may detect bitterness more acutely, it doesn't necessarily make the flavour experience stronger overall. When you're building a sensory panel or thinking about who should be taking part in sensory analysis, super tasters can provide valuable insights, but it's really important to maintain a balanced panel that reflects the typical consumer experience. And like anosmia represents nose blindness, ageusia refers to the complete loss of the sense of taste, which can significantly impact an individual's enjoyment of food and beverage. Ageusia can stem from various causes, including neurological conditions, certain medications, head trauma, or infections that affect the taste buds. Moving on to touch. So, mouthfeel is where we're going with this. Mouthfeel is a unique sensory experience that combines tactile sensations with chemical interactions. While taste and aroma are well studied, mouthfeel is still relatively underexplored and under-researched. So let's take astringency as an example. It's sensed through tactile receptors and creates a dry, puckering feeling in the mouth, generally caused by polyphenols. Now, the polyphenols bind to salivary proteins, reducing lubrication and leaving the mouth feel dry and rough. Temperature also plays a role. It's detected by thermoreceptors for hot and cold, but some compounds like menthol or capsicum can chemically alter our receptors, making the mouth feel cool or warm. Carbonation, another fascinating example for mouthfeel. Perceiving bubbles in beer or sodas relies on two different receptors, a chemically triggered sour receptor and a tactile receptor that senses bubble size. Both of them need to work together. So if you inhibit just one of those, the perception of carbonation will disappear. Mouthfeel is a major factor in how consumers judge quality, and yet so much remains to be learned. Misunderstandings still exist. For instance, the idea that exposed trigeminal nerves influence mouthfeel under normal conditions, which just isn't the case anymore. So, fullness, viscosity, and density are often perceived before you even taste or smell a sample. Simply picking up a glass with a drink in it can give clues about a liquid's properties, its weight, texture, or density, without even taking a sip. And this is especially noticeable with colourless liquids like water, where physical cues are key. The body's initial interaction with the sample provides important information that shapes the overall evaluation. Viscosity and density are sensed the moment the glass is held, long before the liquid enters the mouth. In fact, these early sensory cues of fullness, thickness, and weight help set expectations for the tasting experience. Recognizing that perception begins upon handling. It highlights how the timeline matters in sensory evaluation. Our first physical contact can influence how we perceive flavour, texture, and quality throughout the rest of the tasting. As we consume food or drink, our perception of mouthfeel develops progressively. The initial bite reveals surface texture, whether it's crisp, soft, brittle, or creamy. In beverages such as beer, the first sip may bring a sharp, lively sensation from carbonation. This is followed by changes during chewing, such as melting, and how the food breaks down in our mouths. We assess fullness and texture, such as creamy or crisp. Finally, lingering sensations such as astringency, chalkiness, fatty coating, or alcohol warmth form the lasting mouthfeel, leaving a final impression of quality and character. So, carbonation plays a key role in how sparkling beverages are perceived. The mouthfeel of fizz, as I said, involves both sour taste receptors and tactile receptors that detect bubble size. Together, these sensations shape the overall perception of quality. So, natural carbonation, like in bottle conditioned or cask conditioned beers and champagnes, produces small, slow growing bubbles that create a smooth, elegant carbonation. Forced carbonation, on the other hand, manipulates gas solubility with temperature and pressure to produce larger, faster growing bubbles, giving a sharper, more stinging sensation. The rate at which bubbles grow depends on the CO2's initial state, whether that's dissolved or, in the case of bottle conditioned or cask conditioned, in a nanoemulsion state. Interestingly, the oral perception of carbonation will dissipate almost immediately after swallowing, making it a fleeting but very memorable part of the sensory experience. While we often focus on taste, aroma, and mouthfeel, sound also plays a really important role in how consumers perceive quality. We mentioned before about the hiss of CO2 from a can of beer or soda, or the crunch of a carrot. That's an auditory cue that will set expectations around the freshness of the product. When familiar sounds are missing or different, consumers notice it immediately. In sensory evaluation, even background noises, so if you're preparing samples, the difference between opening a bottle versus a can introduce a bias to your tasters. And this highlights the importance of controlling the environment where sensory analysis of your products is taking place to ensure consistent, reliable results. Okay, so having explored each of the five core senses, it's easier to see how they interact to shape our perception of food and drink. Appearance is often the first thing we notice, setting expectations for flavour and quality. Sound, from the hiss of a carbonated drink to the crunch of a crisp snack, also influences our experience. Smell is particularly complex, working both orthonasally and retronasally, which can create different perceptions of the same product. Touch informs how a product feels, so smooth and creamy in a dessert or light and crisp in a refreshing beverage. And finally, taste adds the last layer, from bitter to sweet, completing the flavour profile. By assessing sensory panelists' reactions across these senses, we gain a holistic understanding of product quality. But our senses aren't perfect, they can also be fooled. Our brains construct flavour from the cues we receive, even if some inputs are missing. The colour orange, for example, can make us perceive citrus. The aroma of citrus can make something taste more acidic. And vanilla can trigger a sense of sweetness, even when none exists. In fact, it's a common tool used in sweetness reduction to add more vanilla. What this shows us is that our senses don't directly inform each other. Instead, they feed information to the brain, which pieces together a full sensory experience. Flavour is far more than just taste. It's a composite of all our senses. When we take a mouthful of food or drink, the brain integrates multiple sensory inputs to create a complete perception. We don't just notice bitterness or sweetness. We experience aroma, texture, temperature, and sound. The pop of a bottle cap, the intensity of a product's colour. Each detail subtly shapes expectation and enjoyment. So, to truly assess product quality, these sensory stimuli must be considered both individually and together. Now, analytical methods can quantify compounds, but they can't predict the way the flavour fits together holistically. For example, while diacetyl concentration may correlate with a buttery note, complex attributes like body or mouthfeel remain harder to define chemically, and context matters. A measurement meaningful in one product may not translate to another. Moreover, perception isn't isolated. The brain integrates multiple cues and can even compensate for missing or conflicting signals. Humans are uniquely equipped to assess food and drink holistically. Traditional models list five senses, but as I said, modern research recognizes many more, all interacting in complex ways to shape our perception of the world around us. As sensory science evolves, advances in neuroscience and artificial intelligence are uncovering new dimensions of flavour perception. We're only beginning to understand how the brain processes sensory information, and future discoveries will continue to reshape our understanding of flavour, perception, and even consciousness itself. By seeing our senses as an integrated system rather than isolated channels, we can better grasp the complexity of perception, whether in food and drink, scientific research, or everyday life. And so, to wrap up today, we've explored how appearance, aroma, taste, mouthfeel, carbonation, and sound interact to create the flavour experience that consumers respond to. The key insight is that our senses don't work in isolation. They feed information to the brain, which constructs the overall perception of quality and environment. Understanding these sensory inputs helps you design, evaluate, and refine your products so that the experience matches consumer expectations. Combining sensory evaluation with analytical methods gives you a holistic view of product quality. Now, don't forget, our Roxa team, which includes myself and Gordon, is here to support the development of your sensory panel in a variety of ways. We can guide you on the key flavours in your sectors, provide flavour standards to calibrate your panel, deliver taster training, and support the validation of your taster's proficiency. So if you'd like to explore any of these, please reach out to our team at sales@aroxa.com. We'd be really happy to help. Today's webinar is an introduction to our upcoming e-learning platform, Nexus, where you'll soon find self-guided training material. It will be a comprehensive learning resource covering brewing and beverage technology fundamentals, as well as microbiology and quality management. You'll also gain access to problem solving tools for real production challenges and sensory training, including flavour standards, validation exercises, and guidance on building your in house sensory panels. All of this is delivered through practical, interactive, self-paced modules, giving you the flexibility to learn on your own schedule so that you can learn anytime, anywhere. Nexus content is applicable for everyone from small batch craft producers to multinational organizations and complements the Aroxa kits, training courses, and consultancy. It's bringing all of our expertise under one platform. So if you'd like to sign up for updates about the arrival of Nexus, you can scan the QR code on screen here and give us some details to stay in touch. So I'll pop this QR code back up on the screen after the Q&A section. But if you do have any questions, now is probably the time for us to tackle them. Gordon, have we had any questions?
I've got a couple here from me. There's still time for people to add if they'd like to just pop it into the Q&A box there. Don't be shy. You can submit anonymously as well if you're worried about thinking that it might come across, but there's no such thing as a stupid question. Yeah, one for me, Jen. You'd mentioned humans can distinguish between different isomers of the same compound. I just wondering if you could give an example of why that would be important or relevant.
Okay, so I'm going to do this in the world of beer because that's my background. If you are a brewer, you'll be very aware of trans-2-nonenal, which is the compound that is associated with a paper character. It's a stalingaldehyde that's related to the taste of paper in beers, and it becomes more apparent as product ages over shelf life. That has a similar isomer, which is a compound called cis-6-nonenal, which looks very, very similar on a GC chromatograph because similar molecular weights, they look pretty much the same when you just write them out as a formula, but has a really massively different characteristic. So cis-6-nonenal has the characteristic of melon. So paper, melon, very, very different. But when it comes to analytical results, they're going to look really similar on a GC plot, which is where training your tasters really comes to the fore because humans can make that differentiation.
That's very interesting. I have a question here. You mentioned that the appearance, aroma, texture, flavor, sensory evaluations are becoming outdated. Do you have any suggestions of a good scale or attributes to evaluate prepared food?
Off the top of my head, no, but what I would say is that's only because you've caught me on the hop. Any questions that you do actually have to ask, we will happily break down after the session and reach out to people by email. Gordon, that's a really good question. I suspect there are some people on this call who would love the answer to that. So we'll
Yeah,
work
I
up
think
a proper answer to it and maybe share it out with anyone who might be interested. Just let us know if you want the answer to that question.
Yeah, I believe it's something that our colleague Pri is currently working on in quite a lot of detail with. So we've definitely got some information on that that we can get out to people about all the work
Brilliant.
she's been doing. Um, okay, another one. So you also talked about detecting people with anosmias prior to building a panel. Would you suggest that if you just there's particular anosmias that you should remove them? What's the value of having people that you know have anosmias within your panel?
Okay, so the most important thing is that your tasters are good tasters. Being a good taster doesn't mean that you have fewer anosmias, but it means that you can repeatedly recognize specific compounds that you've been trained on and use a consistent language to describe them. Now, if you're setting up a sensory panel, we would always recommend that you do screening tests initially to pick the best tasters in your facility. Um, those screening tests might highlight anosmias. You're not really looking for people to get every single thing absolutely correct, but you are looking for people to be able to do it repeatedly. The benefit of having tasters on your panel if they have an anosmia is that if you know what that anosmia is, so for instance, Gordon, I know that you've got an anosmia to geosmin earthy compounds, means that if something crops up in a tasting session and maybe you haven't picked it up, but three other people have done, we can utilize through a process of elimination, knowing what your anosmia is, we can utilize that to work out is that the earthy compound that we're maybe picking up, or could it be something else? So I don't know if I explained that terribly well there, but essentially, if you know what your tasters can't pick out, it means that through that process of elimination, you can really hone in on what the faults or problems might be that your sensory panel are picking up on.
Yeah, fantastic. No, I think that's a very good answer. I don't think I could come up with anything better than that. Um, in terms of sensory panels, you mentioned things about environmental control, obviously making sure the difference between like a sound of a bottle or a can is going to lead them towards a certain way. What are the other key factors for environmental control for tasting?
I'm going to do a small plug here because this is a lot of the material that's going to end up on the Nexus platform. We have an entire course coming up that will be available for you to understand how to build not just a sensory panel of tasters, but set up the tasting environment, what sort of controls you need to consider. At the end of the day, in a sensory evaluation session, you want the tasters to have as little information as possible because any information will give them a bias. What that means is you're going to control temperature, you're going to control the environment that they're in, you're going to control how the samples are presented and served to them. Ideally, you're not going to tell them what it is. The serve size is going to be really consistent. If you're doing liquids, maybe you're pouring them literally at just before, just in time, so they haven't had a chance to sit around and lose carbonation. If there's a variable that can be pulled into question, you need to find a way to control it. Now, we give a lot of information about that in the course that we'll be launching onto Nexus either later this year or early next. So, if it is something that you want to dig into more detail on, maybe you are a panel leader on your site, look out for that. We'll be trying to make your life a lot easier through that course.
Right, fantastic. I've got another question here asking about specific studies, but I'm going to get back to them to ask us to send us an email because I don't think we'll have that stuff to hand at the moment, but it will be on file somewhere. So I'm going to type an answer back to you with an email address so you can get in touch with us and we'll continue to discuss them.
Fantastic.
Um,
That's brilliant.
yeah. Would you like one more, Jen?
Yeah, go on, be gentle.
Okay. I just think on the salt adaptation you mentioned, like, is that quite a hard and fast rule of like how long it takes, or is it one of those quite variable things?
Uh, Tasters are very unique people, so it's going to vary from person to person. Obviously, you can't be in control of how much salt your panelists might be eating at home, but through screening and validation exercises, you'll be able to understand whether their thresholds are moving. In terms of being able to adapt your own sense of salt or taste, it will vary from person to person. No real hard and fast rules on it because we're all unique individuals.
Fantastic. Um, so I just got one more here, if I'm not keeping you, Jen.
No,
Is that
I'm
okay?
delighted to know the questions are still coming in. And I say if we don't get a chance to come back to your questions a bit too specific, we'll follow up afterwards anyway.
So you mentioned that you always serve drinks to the panel at the same temperature. So it's important to keep a consistent temperature. Is this the temperature they typically be consumed at, or do you standardize it to room temperature for consistency?
We have customers who do both, don't we, Gordon? What's your experience of it been?
I think it very much depends on what they're using the panel for. If they're using it for quality checks where there's particular things that they're looking for, we'll often see it done at room temperature, but when it's like preference, they will tend to do it at what it's served. It's a bit of a mix. When we do training, we tend to do it at dispense temperature. Um, we let it warm up a little bit because it makes it easier. You don't want it like too cold because then it's much harder to detect certain flavors. But it's yeah, I guess it kind of depends what the purpose of your sensory is.
Probably the most important thing is that it's consistent. Ideally, you want to know that the results you get in week one match the results in or are repeatable following the same protocols that you might do in week 15, 16, 17. So there's yeah, exactly what you just said. There's no hard and fast rules. Um, what is it that you want to get out of the test is a really good way of looking at that.
Yeah, I think if you start with one, make sure you stick with that one. Otherwise, you're going to be throwing your data all over the place.
Yeah, amazing.
I think that's it for the questions, Genevieve.
Okay. Well, we're doing quite well for time. So there's a bit of a sneak peek here. So we've got the next in our series of webinars. This was the first in a series of free webinars coming from Cara Technology and Aroxa. We are a company that specialises in flavour chemistry and quality management in food and beverage businesses. Our next webinar is going to be in 2 weeks' time on October the 8th. It's positioned for the brewing industry, but of course, the learnings from it can translate to any process optimization regime that you might have in your food or beverage operation. So, we'll be talking about optimization of sustainability without compromising sensory quality. It is a talk to partner with a poster that we presented at the CIBD Sustainability Conference back in July. And you will be with me again, though I would hasten to add that you won't always be with me. Please join us for this webinar series. We've got a myriad of fantastic experts in our business who will be very keen to share their knowledge with you over the coming months. In the meantime, that's here's the QR code again. If you do want to sign up for some more information about Nexus, our new learning and education platform. Otherwise, thank you so much for joining us for today. Enjoy the rest of your day, and we really look forward to connecting with you again soon. I'm going to leave the call open until for another 10 minutes. So if you do have any more questions, Gordon and I will be on in the background. We'll be able to field them a little bit there. And it also gives you a chance to scan that QR code as well. Otherwise, thank you so much for joining us for this session, and I hope it sparked some ideas about flavour and sensory perception for you. Have a great afternoon.